The JWST, or James Webb Space Telescope, has demonstrated a remarkable phenomenon: illumination in the form of beams coming from light years away, a faraway city. This revelation has rekindled the fire of discussions regarding the possibility of civilizations from other planets. The telescope concentrated its attention on the closest known exoplanet, Proxima Centauri b, in our solar system and detected unusually intense light bursts. Could the presence of these emissions be an advanced alien society? Keep an eye out for additional updates. For many years, both public and scientific communities have been enthralled by the concept of life beyond Earth. There is no sign of life on other planets has been met with a lot of enthusiasm. A big breakthrough was made by the JWST, providing convincing evidence that the existence of life in other parts of the universe, as we look at the vastness of space, is so potent. The instrument found something remarkable on an exoplanet far away, resembling those from human-made cities, increasing the likelihood that an alien city can be found in that faraway world. The result of this discovery is a lot of excitement. An interest in the scientific community because it could symbolize the breakthrough they have anticipated for a long time, suggesting the existence of intelligent societies in ways that we are just starting to comprehend. By observing these city-like lights from a remarkable NASA, located 4 light-years away, engineers are astonished when they consider how long they might have been in space, awaiting our technological advances development to locate them. David Kipping, a Columbia University astronomer, has described the planet on which these lights originated as particularly complicated. Unlike the majority of rocky planets which absorb sunlight and infrared radiation, radiation on this exoplanet behaves differently because of its different relationship with the star of the show, Proxima Centauri. This discovery demonstrates the significance of JWST's ability to capture wavelengths in the infrared, which were crucial for spotting the unusual Proxima Centauri b's behavior, which is important for comprehending the planet's atmospheric conditions. According to researchers, they will keep making use of the telescope to investigate the planet's atmosphere in more detail in the hopes of determining its potential to become habitable. The JWST is especially skilled at detecting infrared light, which allows it to see things on Proxima Centauri b that many telescopes have trouble detecting at night in the vast darkness of space. But the JWST does a great job of picking up even the tiniest glimmerings. This makes it a great tool for determining whether the alleged city lights on Proxima's dark side, if true, can be detected. The telescope can detect artificial light provided that it falls within a much smaller frequency range than the light from regular stars in the vicinity. Proxima Centauri b has an active interaction with its star, having a significant impact on its environment, like that of many orbiting planet stars. It draws a lot of energy from Proxima Centauri during the planet's rotation. It goes through periodic cycles like the night and day on Earth, during blistering heat during daytime temperatures and nighttime temperatures. The temperature range on Proxima Centauri b is huge. It's primarily because of its composition, such as the planet having a temperature-controlled atmosphere. The time of day and night would be sweltering on one side and icy on the other. Is striking. Thermal fluctuation is one important area of interest for astronomers because it offers useful hints regarding Proxima Centauri b's atmospheric composition. The JWST and its aptitude for infrared imaging spectrum is able to thoroughly investigate the planet's thermal emissions, offering insights into the characteristics of its atmosphere. The JWST's orbit coincides with the orbital path around Earth, enabling Proxima Centauri b scientists to conduct in-depth research of its daylight cycles every 11.2 days. In the event that Proxima Centauri b has an atmosphere, the next action will be to examine its chemical makeup to determine whether it could sustain life. Detecting substances like water, oxygen, methane, and vapor would suggest the planet's capacity to support life. This would entail studying the light passing through the planet's atmosphere, a complicated procedure, whereas the JWST is excellent for describing the planet's environments. It is primarily intended for other jobs in which it is proficient, evaluating the concentrations of water vapor, methane, and carbon dioxide, but it is unable to detect free oxygen as effectively, an important sign of life. Still, the telescope can look for different key indicators, such as ozone, which indicates a healthy environment. As scientists investigate the information gathered by the JWST, the hunt for distant worlds continues, bringing us closer and closer to a response to the inquiry of whether we are the only ones in the universe. It is essential to keep in mind that the JWST is limited in its ability to study the number of the closest exoplanets to Earth. For more in-depth research on planetary atmospheres, astronomers will use observatories on the ground like the ELT, or Extremely Large Telescope. The ELT, which will begin operations in 2027, is intended to provide a more in-depth look at the far-off structures of exoplanet atmospheres, providing more detail and clarity regarding their capacity to support life. Scientists are eager awaiting the launch of upcoming spacecraft. Meanwhile, telescopes like the ELT and the JWST are still useful tools for exploring distant exoplanets despite their restrictions. The JWST continues to provide important information that could alter our comprehension of what lies beyond our solar system. Scientists have high goals. They have plans for future space telescopes to endeavor to create technologies that cut interfering starlight, allowing for better observation of the surrounding planets. These are similar to blocking the sun with your hand so that you can see better. The capability of these upcoming telescopes to concentrate on the sliver of light reflected by exoplanets makes analysis of their atmospheres simpler and determines whether they may be able to sustain life. However, this is no easy task. Stars are extremely bright, frequently outshining the planets around them. Because of the brightness, it is difficult to detect the planet's faint light reflected, which is necessary for studying their qualities. To deal with this problem, researchers are tackling several novel methods, one of which calls for the utilization of coronagraphs, instruments inserted into telescopes to block out the sun's rays while allowing the planet's light to pass through. By carefully arranging the waves of light, coronagraphs have the ability to greatly reduce the star's brightness, making it simpler to recognize the dim light from exoplanets. Another promising method, the starshade, is the size of a huge flower-shaped spacecraft that will carry data using a telescope positioned tens of thousands of miles away. The starshade prevents starlight from reaching Earth, allowing only the light emitted by exoplanets to reach the telescope's instruments. This method might be especially useful for observing planets in the zone of habitability where liquid water and possibly life exist. But these new technologies necessitate exceptional precision, such as the starshade's alignment, which must be perfect 2mm level precision over extensive distances. These innovations need to overcome the limitations that space missions impose, including the requirement for miniaturization, the capacity to save energy, and the ability to withstand the harsh space environment. Despite these challenges, the possibility of successfully observing and evaluating the environments of exoplanets may result in enormous rewards. Chemical biosignature discovery. Oxygen is one of the indicators of life. Specifically, methane or water vapor ratios suggest these molecules may indicate biological processes. Researchers believe that life exists beyond Earth. They are also looking into direct imaging techniques for a closer look at distant worlds in the future. Telescopes may be outfitted with sophisticated adaptive optics that adapt for Earth-induced atmospheric distortions or the motions of the telescope, resulting in sharper images. Combined with technologies that block starlight, these enhancements may enable scientists to go beyond just finding exoplanets and to examine and map their surfaces, climates, and future development. The next generation of space telescopes is a significant advancement in our efforts to answer one of humanity's most profound questions. Are we the only ones in the universe? By increasing our capacity for observation, these far-off planets we are seeing bring us closer to confirming that life does exist beyond Earth, which could change our comprehension of our position in the cosmos. The future of space exploration is advancing at a rate never before seen as astronomers and scientists delve deeper into the enigmatic worlds of faraway exoplanets. A new era of cosmic discovery is being heralded by the JWST. The information gathered is assisting astronomers in uncovering revolutionary details regarding the structure, composition, and potential habitability of distant worlds. With each new piece of information, we are getting closer to the ultimate query. Is there life beyond this world? The discovery of Proxima Centauri b, our planet's closest known exoplanet, could be only the beginning of a significant turning point in how we study life on another planet. Proxima Centauri b, being the star closest to our own solar system, has received a lot of attention for a long time. However, until now, locating tangible evidence of life, such as signs of artificial light or civilization, remained aspirational. The fact that such light has been discovered by the JWST not only increases the hope that we might one day contact additional intelligent organisms in the universe, but also fuels both public interest and scientific curiosity. This creativity inspires new generations to consider alternatives to Earth. As the JWST keeps making observations, it's not just looking for artificial lights, but also focusing on the atmospheres of planets, their chemical makeup, and how these factors may support life. Biomarkers like methane or the right side of carbon dioxide are essential for determining whether these planets have ideal living conditions. The JWST possesses the capacity to examine components of the atmosphere like no other telescope has been capable of, illuminating the potential of faraway worlds to sustain life, similar to Earth's. One of Proxima Centauri b's most fascinating aspects is its location in the star's habitable zone, where liquid water may thrive in the right conditions. The ability of water to exist on its surface, in the area immediately surrounding a star where the temperature is just right, neither too hot nor too cold, for liquid water to form, is regarded as an important aspect in determining whether life could exist on this planet. Water is essential to our understanding of life, making the finding of an exoplanet inside a star's habitable zone a major target for future tasks. In addition to discovering planets that support life, the target of future space telescopes will also be the complex interactions among exoplanets and their stars. Some planets, like Proxima Centauri b, are tidally locked, implying that one side always faces the star while the other side remains dark. This may result in high-temperature distinctions between the two sides of the planet that would impact its climate and potential to support life. Comprehension of these conditions is crucial for astronomers in their evaluation of the likelihood of habitable environments on exoplanets. The growth of technologies for preventing bright starlight is another important advancement in space exploration. Without the capacity to isolate starlight, it would almost certainly be impossible to see the faint light from faraway planets. Technologies like the coronagraph and star shading, cited earlier, are excellent examples of how researchers are approaching this challenge. By blocking the dominant brightness of the host star, telescopes with these instruments can detect the dim light that comes back from orbiting planets. This light may contain vital information about a planet's surface, atmospheric conditions, and even its capacity to accommodate life. A particularly exciting development in this realm is the idea of direct exoplanet imaging. By utilizing cutting-edge adaptive optics and light-blocking instruments, astronomers aim to capture high-resolution photographs of planets as they orbit their parent stars. These images could not only provide additional insight into a planet's atmospheric properties and chemical composition, but also display features like rivers, lakes, or large-scale weather systems, giving humanity a look like no other at faraway worlds. Such capabilities would represent a significant advance in our search for habitable exoplanets and significantly enhance our comprehension of their ability to preserve life. As the worldwide effort to explore the universe intensifies, the James Webb Space Telescope JWST, together with upcoming missions, will play a crucial role. The JWST's ability to spot subtle energy signatures, separate atmospheric components, and evaluate potential biosignatures is redefining contemporary astrophysics. As scientific advancements and technological progress continue, our proximity to information that may completely redefine how we think about life in the universe grows. The rapid advancement in astrobiology and space exploration is presenting new opportunities. Astronomers and researchers are continuing to investigate the cosmic unknown, led by the JWST erupting into an adventurous new era of discovery. The plethora of information it provides allows astronomers to draw groundbreaking findings regarding the chemistry, structure, and habitability of distant exoplanets. Every new data point brings us one step closer to answering one of the most pressing issues facing humanity. Are we alone in the universe? The unique features of Proxima Centauri b's characteristics could represent the start of a revolutionary change in how we deal with extraterrestrial life. Being the closest known stellar neighbor to our own solar system, Proxima Centauri b has been the focus of extensive scientific research for a long time. Till now, observable evidence of alien life, such as artificial light or signs of intelligent infrastructure, remained purely hypothetical.